Hi, and welcome back. We're now in week 5, spring 2021 semester, computer assisted mechanisms, and this is our 5th lecture. Not doing a test yet, but soon. We have a few more things to cover before we get to a test. So what I'm going to do is share my screen like usual. Let me turn me off here, and we'll have a look. Here's Blackboard, and what we're working in. Pick one of these classes here. We're working under lessons and slides 2 is where we're going to find the slides that we're going through today. So let me pop that open. And we'll just go down to where we left off. So we had done, thermistors and potentiometers. We're going to talk about switches today. So let me get down to that. All right. This sounds really simple, and it is, but two things we have to talk about with switches is ground side switching and power side switching. So the signal or the information coming from a switch is, pretty simple. Either it's on or it's off. And, a lot of times we say 1 or 0 for on or off. Power side and ground side we'll explain in a minute. So on a power side switch, when the switch is closed, the voltage goes from 0 to 1. Now that might be 0 volts to 12 volts. Usually it might be 0 volts to 5 volts. Ground side switch, when the switch is closed, the voltage goes from 1 to 0. In other words, what's sensed at the computer drops from whatever it starts at, 12 or 5, down to 0. So here's a picture. If we look, this is the switch right here, okay, on this top slide, this top example. And the way this is shown, switch is open. So let's get rid of these. Current doesn't flow. This here is basically a voltmeter lead, and this is basically a voltmeter. So it has high impedance. There's going to be no current flowing down this line here. It's like the red lead on your voltmeter. And this here is like the black lead on your voltmeter, and you see it's connected to ground. So what you're going to see with this no current flow here, you just see there's no voltage drop at that resistor. The voltage on this line is going to be whatever the voltage is up here. So in this case, 12 volts. Let me clear all that. So when this switch closes, what you're doing is you're pulling this to ground. You're basically connecting this to this. And you know what happens when both of your voltmeter leads are on the same thing? It reads 0. So you're essentially closing the switch is pulling this line here to ground. It's connecting it to ground. So the voltage you read is going to be 0 volts. So that's our first example. That's one way of doing it. That's where, really simple, just using 12 volts, like off an ignition switch or something like that. Second example down at the bottom here is more typical of our actual sensor circuits, right? The 5-volt voltage regulator built inside the computer. And notice the resistor is inside the computer now, right here, right? And so out here, on this line, with the switch open, you're going to measure 5 volts. Why are we going to measure 5 volts? We're going to measure 5 volts with the switch open because with no current flow down this line, there will be no voltage drop across this resistor. We're going to read the full source, 5 volts in this case, here at the voltage sensing circuit. When we close this switch, again, we're taking this voltmeter lead, right? We're connecting it to ground, and this voltmeter lead is connected to ground, right? We're basically pulling this wire down to ground. And so the voltmeter here is going to read, you guessed it, right? 0. Well, that didn't work out too well. 0 volts. So this is ground side switching, done both ways. So when you push a button on your dash, very possibly, like let's take the example of maybe a power window circuit. In the old days, that power window circuit, what the switch did was connected battery voltage through the switch to the power window motor. That typically doesn't happen anymore. Typically now what happens is you have some sort of a computer, like a driver's door module or a passenger door module, and the switch is just simply an input like this, right, to the computer. And so when you push that button, the voltage sensed at the computer changes. So that's how the computer knows, if you will, that that down button or up button's been pushed, by watching that line and seeing it change. Then the computer, from that point, it takes care of opening or closing the window. So, why do things this way? Let me just give you an example. The last car I had, if you held the unlock button on the remote down for an extended period of time, all of the windows in the car would go down. Now, that wouldn't be possible without the computer controlling the windows in the car. Another thing, it just makes the one-touch down thing a lot easier. When the computer sees a momentary, change on that circuit, it knows you've just hit the button quickly and the window will go all the way down without having to hold the button. Same sort of thing, think about it. Your ignition switch on the car used to be power running through that ignition switch to the fuse box, to the starter. That doesn't generally happen anymore. The ignition switch now is just a sensor. You push that start button, the computer sees the voltage on a particular wire change, either goes from high to low or low to high, and when it sees that, it understands that you've pushed that start button, and then as long as all the other conditions are correct, like it sees the correct position of the shift selector, it sees that your foot's on the brake, which is another switch we'll talk about in a second, and when it sees all those conditions are correct, it starts the vehicle. The advantage of doing it that way is, with the computer, rather than the old-fashioned way with the ignition switch sending power directly down to the starter or to a starter relay, is remote start becomes, something that's just kind of built into the vehicle. You don't need a separate device for that. Since the starting process is completely in the hands of computers, all we need to do is find a way for that keyless entry module or whatever module is picking up the signal from your key fob to just communicate on the network to the powertrain control module. Hey, the driver wants the car started, and so then the PCM will start the car, and so we don't have to add a remote start to the vehicle. It's just a matter of adding some software, adding some lines of code. So I mentioned the brake light switch a minute ago. Take a couple examples. First, let's talk about how this switch works. This is a lot simpler, right? We have battery voltage, switch is open, so nothing sensed at the computer on this line right here. Switch closed, then this 12 volts is sensed here at the computer. It knows that that switch is closed. So let's pretend that this switch here is the brake pedal switch, right? Down on the brake pedal. What could that be used for? Well, I'll give you two examples. So the first one we just talked about, right? You go to start your car, you push the start button. If the computer doesn't see 12 volts on that pin from this brake pedal switch, it's not going to allow the car to start. So that's one possibility for it, right? Talk about another, we'll go to automatic transmissions. And you've all taken automatic transmission, so you understand a lock-up torque converter. Torque converter clutch essentially takes the fluid drive out right between the engine and transmission and makes it a solid mechanical connection. That's great when you're driving down the road, but if you come to a stop sign and you have a solid mechanical connection between the engine and the transmission's input shaft, the engine cannot continue to run while the vehicle doesn't move. That would be like driving a manual transmission car and forgetting to step on the clutch pedal when you come to a stop sign. So in order to keep things like that from happening, the powertrain control module is monitoring that brake light switch, right? And so if it sees battery voltage at a specific pin, right, well, the pin going into the computer that's associated with that switch, it will disable or unlock the torque converter clutch so that we don't get to a stop and have the engine and transmission still locked together. This circuit probably would also branch out to another computer, right? To a lighting control module responsible for turning on the brake lights. So one sensor doing both things. Or here's another way. Think of it this way. You got to start thinking about things this way, right? Instead of branching out, right, where the signal goes to, say, this is the PCM, and then another signal goes to a separate computer, right, like I just talked about. If we get rid of this idea and say, okay, there's a separate computer, so we'll say this is a lighting control module, right? Lighting control module. And, this is the PCM maybe. I don't draw very well with a mouse. But just a network connection between these two guys, right? So step on the brake pedal. PCM sees the voltage at this pin here, right? Knows that you've stepped on the brake, says, okay, I'm good. I have one of the conditions I need, either to start the vehicle or to lock up the torque or unlock the torque converter. I'm also going to send a message over the network to the lighting control module that the brake lights need to be turned on. Could it go the other way? Yeah. Maybe this is the lighting control module, right? Instead, and so the brake light switch goes to the LCM, and then the PCM sitting down there on the network, that's supposed to be a P. Right? Maybe the lighting control module across this network tells the PCM the guy stepped on, the driver stepped on the brake light switch. So it can work either way. Another setup you might have, and this is a bad slide, so what I'm going to do instead of using this slide is, let me just start up a spreadsheet here real quick. So we'll just do a blank one, right? And we could have maybe, we'll talk about an automatic transmission. And we'll say, if you've taken automatic transmissions, which really you shouldn't be in this class unless you've already been through that, but maybe it happened. I'll just take a simple 4-speed automatic. So going forward, we're going to have a forward clutch. We're going to have a, let's say, an intermediate band. Maybe a direct clutch. And possibly some sort of overdrive clutch or band. I'll say an overdrive band, right? Don't know why my capitalization is so. There we go. I feel better. Okay, so we have these 4 devices, and so maybe first gear, right? I'll call this first gear. We'll say second gear. It's not supposed to be there. Third gear. And overdrive or fourth gear. And I don't know if you've ever seen a clutch and band application chart, but that's kind of what I'm creating here, I guess. So if we're going forward in one of these simple old 4-speed automatics, the forward clutch is going to be on in every one of these gears. So we'll just put it on in all of those, all right? Yeah. So second gear, maybe the intermediate band comes on. That gives me my second gear. Third gear, maybe the intermediate band comes off and the direct clutch comes on. And fourth gear, yeah, maybe we have all of these except for the intermediate band on. It's been a while since I taught automatics, so bear with me if I have something messed up. But what you can see is that just by looking at the things that are on, right? So for example, if the forward clutch and the intermediate band are both on, we know we're in second gear, right? If the forward clutch and the direct clutch are both on, we know we're in third gear. If all three of these things are on, we know we're in fourth gear. And if only the forward clutch is on, right? Only the forward clutch, right? We're in first gear. All right. So each one of these devices, right? Each one of these, they each are fed by some sort of a hydraulic circuit. And this hydraulic circuit can have a pressure switch installed in it. And so the computer can have 4 pressure switches, one for each of these, right? You could throw one in for reverse too. I won't bother. But so I could just look at those pressure switches, right? And if the computer sees that the switch for the forward clutch is turned on, but all the others are off here, right? They're all off. Then the vehicle's in first gear, right? If instead, right, these 2 switches are on, right? Forward clutch, intermediate band, so there's pressure in both of those passages, that's second gear, and so on. So here's the logic, right? Driving down the road, this automatic transmission, it's looking at the vehicle speed sensor, right? So the PCM is looking at the vehicle speed sensor. And the old mechanical transmissions worked this way. I know this isn't tranny class, but they had a throttle valve, which was connected literally to the throttle, to the accelerator pedal in some way, shape, or form. And they had a governor, which was spun off the output shaft of the transmission. So pressure coming out of that was dependent on the RPM of the transmission output shaft. In other words, how fast the car was going. So all they've done with electronically shifted transmissions is they've switched to electronic versions of those things, right? So instead of a throttle valve in the transmission, maybe they're using the accelerator pedal position sensor or the throttle position sensor to determine the driver's demand. In other words, how far have you stomped down on that loud pedal? And then using a vehicle speed sensor, right, a type of sensor we're going to talk about in a few minutes, vehicle speed sensor, to determine just how fast the vehicle's going, right? And it's using those two pieces of information to decide what gear it should be in. So we start out from a stop, and we're in first gear. We're in drive. We're in first gear. So that means, that here's the situation. Just this clutch is on, right? So that pressure switch is the only one turned on. So the computer's got these 4 switches feeding it. It's kind of like what we're trying to show here, but this is not a great slide, right? So it's showing a bunch of ground side switches, normally open switches. And so, like I say, this slide's not that good, so let me get out of it. And so seeing that only one of those switches, only the one connected to the hydraulic passage for the forward clutch, has pressure in it, the computer knows, okay, I've commanded first gear by operating the shift solenoids, for first gear, and because that pressure switch has turned on, I know that that shift happened, or at least I know that that shift valve functioned and sent hydraulic pressure into that passage to the forward clutch. So that's basically a feedback loop, diagnostics, so that if the computer commanded that forward clutch on and it didn't see this switch change, close as the pressure hit that passage, it would know there was a failure with that shift solenoid or a shift valve. Something in the hydraulic system didn't send pressure into that passage. So now the vehicle, starts reaching 10, 15 miles per hour. The vehicle speed sensor feeding information into the PCM. And so the computer says, okay, it's time to make that 1-2 shift. So leaving the forward clutch on, but now it turns on the intermediate band too, right? So it's going to look back at this group of pressure switches, and now it expects to see 2 of these pressure switches activated or turned on, closed, whatever. Knowing now that there's hydraulic pressure being sent to the passage, not only for the forward clutch, but also for the intermediate band. And that doesn't mean that the band came on, but it does mean that hydraulic pressure was sent to that band servo. Right, so it's for diagnostics and the ability to know that a shift has been commanded hydraulically. So in a minute, we'll talk about how the computer would know that the shift actually occurred. That band could be smoked, right? And just because you sent hydraulic pressure to it doesn't mean that it actually applied. But how can we tell that it actually applied? We'll get to that in a second. So now the vehicle hits 25 miles per hour, let's say, and so it's time for the 2-3 shift. This intermediate band is going to come off, right? So we'll say, boop, no intermediate band. Now we're going to have still the forward clutch, but we're going to have now the direct clutch come on. And I'm not saying that every, transmission works exactly this way, but this is kind of typical, right? So computer's looking at those switches. It sees that switch and that switch are both on, knows that pressure is being sent to the forward clutch and the direct clutch, and the vehicle should be in third gear. We know at least the shift solenoids worked and the shift valves moved and pressure got sent into those passages. And then fourth gear, very similar, right? It's going to expect to see all 3 of those. And if it doesn't, then it can give you a diagnostic trouble code for a problem with the shift solenoids or some sort of a hydraulic problem. So sometimes the way these switches are talked about, right, is like a truth table. So let's forget the transmission for a minute and go with brake light switch, right? And the, let's see, brake light or brake pedal. Oops. So totally new example here, brake pedal switch. and start switch, right, on the dash. Yeah, we'll go with that, right? So we have these two. And we'll say they are both off at this point. Center all that, okay. So if you push on the start switch, but not the brake pedal switch, right, there's going to be no start, right? If you push on the brake, but not the start switch, there's going to be no switch or no start. Only when you do both, right, then is there going to be a start. So this is kind of this is known as a logical AND, right? So only when both of those are activated, right here, this situation here, only then will the actual, start occur. Right there. So this would be no, no, no. This would be the logic in the computer would be, 0, 0, neither switch, no start. Start switch only, no start. Brake pedal switch only, no start. Both switches, yes, we're going to start it. So this one would be basically yes, we're doing it. Right? So different ways switches can be used in combination, right? So we talked about how they can be used separately, but this is in combination. These transmission switches, a more complicated combination. The brake pedal and start switch, a simpler combination. And, the software engineers, whoever's designing this, can just, decide how you want the logic to work, right? So in this case, it's only going to allow the vehicle to start if brake pedal switch and the start switch are both pressed. Otherwise, no, all zeros, not going to happen. So let me get rid of all this a minute. And let's just talk a little bit more about this transmission because this is a computer-controlled, computer-assisted mechanism. That's the name of this class, right? So it's one of many on the car. In order to know that that transmission has actually made the shift, what needs to happen? So let's talk about first gear, right? So first gear, I'm going to guess we'll have a gear ratio of maybe 1.5 to 1, right? I'm sorry. Let's say 2.5 to 1. Again, rusty because I haven't done automatic transmissions in quite some time, right? So second gear, let's say, 1.5 to 1, making this up basically. Third, in this simple old 4-speed automatic, third was typically direct drive, 1 to 1, right? I don't know why it needs to give me a decimal point here. Let me get rid of that. Wow. All right, wait a minute. We'll just make it text. Yeah, that's not it. I'll get there. Just text. All right. So 1 to 1. And fourth gear, overdrive, in other words, maybe 0.75 to 1, right? So 3/4 of a turn on the input shaft give you a full turn on the output shaft. So I'm not picking up anything out of any specific transmission. This is just kind of a typical 4-speed transmission, the way it might work. And then, reverse might be also that 2.5 to 1, right? Very similar. now we have 6 and 8-speed automatics, and so that would just move to complicate this more. So let's just stick with the simple, 20-year-old 4-speed automatic, just to make this point. So what this means is, in first gear, the computer expects to see 2.5 turns of the input shaft to 1 turn of the output shaft, right? So input shaft speed sensor, output shaft speed sensor, right? And let's say that the input shaft is going, or yeah, 2,500 RPM. The output shaft would be 1,000. Whoops. 1,000 RPM, right? So input shaft is going 2.5 times as fast as the output shaft. So, think of this shift here, right? You put your shift selector, the driver does, into first gear. The computer commands, let me get rid of all this here. Computer commands this, as far as the hydraulic passages, right? Just pressure to the forward clutch. Now it looks at those switches built into the pressure switches built into the transmission in those hydraulic passages, and it verifies that yes, only that forward clutch passage has fluid to it, fluid pressure. So yes, our hydraulics are correctly configured, right? The shift valves are where they're supposed to be, shift solenoids worked. Now the car starts moving, and it can look and compare these two sensors, right? Input shaft and output shaft speed sensor, and make sure that we have the correct ratio. And this will tell it not only are the hydraulics over here correctly configured, but that that forward clutch actually did apply, and that it's not slipping, right? Because if this number was only 500, that is not the correct ratio for first gear. Something is seriously wrong, right? We have a slipping forward clutch. Sees that, goes, okay, we're good. We have a 2.5 to 1 ratio between our input and output shafts speeds. So then you can just follow along, right? So if we make the 1-2 shift, so now this is the way things should look, right? Forward clutch and intermediate band both have pressure in their passages. This ratio here is going to change too if everything's working according to plan. It'll no longer be 2,500 to 1,000. It'll be, don't make me do the math here, but this number will get higher, right? So I don't know, 1,500. What is that? Do the math here. Equals times, what would that be? 0.75, I don't know. Well, all right, so maybe this would be closer to 1,800 RPM. And so when it sees it go from 1,000 to 1,800, okay, we made the 1-2 shift correctly, right? And then third gear, obviously this is going to be direct drive, so both of them are going to be spinning the same speed as long as there's no slippage, right? And then fourth gear, this output shaft would actually be spinning faster than the input shaft. And this is how the computer can see, with the pressure switches, it can see that the shift valves and the shift solenoids worked. And with the input and output shaft speed sensors, it can see that the shift actually occurred and that the clutches and bands and all that are not slipping, that they're actually functioning. So typically I wouldn't do a video quite this short. We have a lot to cover, but a couple things. Today I had my second dose of the COVID vaccine, so I'm feeling pretty beat. Uh, but the other thing, honestly, I looked at YouTube. I looked at the channel where I post these videos, and last week's video has 4 views. I'll bet you 2 or 3 of them are mine, which means you have not yet watched the video that I did last week. If you're not going to watch these, I'm not going to spend hours and hours making them. So, not saying that I quit. I'm just saying that this is going to be a short one tonight. We're just going to stop with that, and we'll pick it up again next week. I'll make it a little bit longer one. Last week's was extra long. So this week is extra short. Next week we'll make it a little bit longer. And just keep paying attention. I'll tell you when a test is coming up. When we hit the rest of these, right? So let me do this. When we hit the rest of these inputs, right? So here's all the inputs. We're only down as far as switches right now. We've got the rest of these to cover. Data streams, we'll talk about a little bit on inputs. We're going to talk about them again on outputs, because this data stream belongs to actually both categories, right? Depending on which end of the conversation you're on. But right now, I was just talking about input and output shaft speed generators, sensors, and actually those are possibly AC generators. And so next week, we'll talk about those. DC generators is basically oxygen sensors. We've got pressure sensors, which are getting to be more and more all over the car. Like, for example, my airbag light comes on. There's something wrong with the occupant classification system, which is basically a digital scale on my passenger seat. That's some sort of pressure sensor, and something's wrong with that. So we'll have to talk about that. Impossible to cover every single sensor that exists. We can just try to give you an overview so that when things go wrong, you have somewhere to go with diagnosis. So that's it for tonight, or today, I guess, depending on when you're watching this. And we'll pick up in a week, and I'll see you in the lab.